What's up everyone, so in today's video, I'll be talking about how you can properly photograph the planets in much greater detail than you could ever do before, or pretty much just improve on your existing planetary astrophotography skills. Whether or not you have very advanced gear or gear that is similar to mine, which includes an all-manual telescope, a T-ring, a T-adapter, as well as some Barlow lenses to help with the zoom. But you can also use a smartphone to photograph the planets as well, but it won't be that detailed compared to a DSLR or a mirrorless camera. So the kind of planetary astrophotography that I'm going to be talking about in this video is the kind where you have to photograph the planets through your telescope or something with a very high focal length to capture the disk of the planets, such as that of Venus and Mars, and perhaps even the rings of Saturn itself. So first of all, you will need to have something that has a very high focal length, such as my telescope right here. This is Astronomy LT60AZ refractor telescope that has a focal length of 700mm, and it can already give you good views of the rings of Saturn, as well as the moons of Jupiter and its cloud bands, although the cloud bands won't be that detailed, and also see the crescent shape of Venus when it's very close to the Earth. But you can also use telescopes that have a focal length beyond 700mm, but photographing the planets that way will be way more challenging if it's just an all-manual telescope, because the field of view you will have in the night sky will be narrower, making it harder to find the planets. But the thing about planetary astrophotography is that bigger telescopes are often better because they will allow you to capture more detail of the planets compared to smaller telescopes, such as a telescope that has a focal length of 3000mm or more. And Schmidt-Cassegrain telescopes are often good for planetary astrophotography, such as a 14-inch Schmidt-Cassegrain telescope. But you'll also need to have a star tracker with you to be able to properly photograph the planets, since a telescope with a very high focal length means that it will not take very long for the planets to move across your field of view, because the more you zoom in into the night sky, the movements of the planets and the stars become more visible due to Earth's rotation, which can make it difficult for you to properly center the planet in the field of view. So you'll also need to have a star tracker with you to be able to properly photograph the planets, especially one that is very heavy duty, such as a Skywatcher Star Adventurer mount, because the telescope required for planetary astrophotography tends to be bigger and heavier, and it can put a lot of strain in your star tracker if it's not heavy duty. However, aside from very big telescopes, you can also use a Barlow lens to be able to properly photograph the planets, if you cannot afford to buy a very big telescope. But they don't necessarily give you better views unless the conditions are really good for you. But you can buy them from telescope stores near you or online, such as Shopee, Lazada, or Amazon. And the thing about Barlow lenses is that they allow you to squeeze more focal length from your telescope. Say for example you bought a 5x Barlow lens and you put it on a telescope that has a focal length of 700mm like my telescope. So 5 times 700 is equal to 3500mm focal length. So in other words, you just multiply the focal length of your telescope by 5 times. But it all depends on the Barlow lens that you bought. But still though, just because you have more focal length doesn't always mean it is better. Because Barlow lenses, like I said before, don't necessarily give you much better views of the planets. But they are a cheaper alternative to buying a very big telescope. But I will leave a link in the description below for you to learn as to what Barlow lens is best for your telescope. And there are also Barlow lenses out there that can act as a T-adapter that you can use to attach to the T-ring on your DSLR camera, thus allowing you to attach your DSLR camera or mirrorless camera onto your telescope. So now, diving into the camera equipment necessary to capture the planets, there's really no universal way of capturing the planets, which means that you can already use your smartphone, a DSLR camera, a mirrorless camera, or a dedicated astronomy camera or a planetary camera to photograph the planets. But for all of them, you of course need to have a telescope. So let's start with smartphone cameras. So in terms of photographing the planets using your smartphone, you can either handhold your device on the eyepiece of your telescope and take pictures of the planets from there, or you can put your smartphone on some kind of smartphone adapter, such as the universal digiscopic smartphone adapter, and put it on the eyepiece of your telescope, and in that way you won't have to hold your device to capture the planets, giving you more stability and more photographic opportunities. So aside from the smartphone, you can also use a DSLR or a mirrorless camera to capture the planets. But that will mean that you will need to buy a few more things to be able to attach your camera to your telescope if you don't have them yet, which is the T-ring and a T-adapter for prime focus, or you can just buy a combined camera adapter and a T-ring in order to do eyepiece projection for planetary astrophotography. And the difference between prime focus and eyepiece projection is that in prime focus astrophotography, your camera is directly adapted to your telescope and the focal length of your camera becomes the focal length of your telescope. Whereas eyepiece projection is where you put an eyepiece in between the camera and the telescope. However, in terms of planetary astrophotography, eyepiece projection is better than prime focus astrophotography. But you can still get good detail using prime focus. But eyepiece projection is better for planetary astrophotography. Also, by the way, since a DSLR camera and a mirrorless camera tend to put a lot of strain in the focus area of your telescope, you will need to find a way to secure your focuser in place so that when you're photographing the planets, your telescope doesn't go out of focus. Especially if you're pointing your telescope very high up into the sky. Also, by the way, if your gear is not very advanced like mine, and you want to photograph things like Saturn, but you have an all-manual telescope and a DSLR camera that you can attach to your telescope, then I've already created a vlog as to how I captured Saturn using the equipment that I have without having a star tracker whatsoever. And I explained there the process as to how you can properly photograph things like Saturn using an all-manual telescope that has a focal length of 700mm. And maybe that can help you improve your planetary astrophotography skills too. But if you have a heavy-duty star tracker, then there's no need. However, aside from DSLR and mirrorless cameras, another better method of capturing the planets is by using a dedicated astronomy camera. And that is a far better way compared to DSLR cameras or mirrorless cameras. Since DSLR and mirrorless cameras are often not the best choice for planetary astrophotography, dedicated astronomy cameras such as the ZWO ASI 290mm Mini mono camera allows you to capture more detail of the planets than you can get with a DSLR or a mirrorless camera. But this also means that you'll be using RGB filters in order to do planetary astrophotography, because mono cameras do exactly what their name says, they only output images in monochromatic color. However, a color-dedicated astronomy camera can also give you good detail of the planets, but a monochrome dedicated astronomy camera is better. And you can use a software called Fire Capture to properly capture the planets using a dedicated astronomy camera and do lucky imaging from there. Also, besides dedicated astronomy cameras, you can also use a point-and-shoot camera to capture the planets properly through your telescope. Although point-and-shoot cameras don't give you full manual control as opposed to a DSLR or mirrorless camera, they can already give you captivating images of the planets themselves. And the advantage of using a point-and-shoot camera is that they have this built-in small zoom lens that you can use to zoom in on the planets even more when you attach your point-and-shoot camera to your telescope. Especially if you can fit the barrel of your point-and-shoot camera onto the eyepiece holder of your telescope. So now that we know the equipment necessary to capture the planets in great detail, the question then becomes as to how we can find the planets and when is the best time to photograph them. And one way of finding the planets in the night sky is by using a night sky emulator app such as Stellarium or Sky Safari, but I use Stellarium to find the planets and as well as figure out when is the best time to photograph them, as well as where they will be in the night sky. You can already download Stellarium for free, and the free version of the app already allows you to know where the planets are, as well as many of the other celestial objects in space. So once you've figured out how to find the planets, the question now becomes as to when you should photograph the planets. The best time to photograph the planets is when they are in opposition, especially when you're trying to photograph a planet that is beyond the Earth's orbit, such as Mars, Jupiter, Saturn, Uranus, and Neptune. But the easier targets are Mars and Jupiter and Saturn, because those things are brighter and you can find them much more easily through your telescope. However, the outer planets, Neptune and Uranus, are simply too far away and too small to be spotted by an astronomical telescope. However, when it comes to the inner planets such as Mercury and Venus, you'll have to wait until they are now at their greatest western or eastern elongation, because it is during that moment that they are at their highest point in the night sky, making it easier for you to find them and photograph them. But Mercury itself is even trickier to photograph than Venus because Mercury is very close to the Sun, and thus it is closer to the daytime side here on Earth. And photographing Mercury means that you will need to have a clear view of the horizon, since Mercury itself lies very close to the horizon, even during its greatest eastern or western elongation. And also, by the way, if it's possible, try to shoot the planet when it is at its highest point in the night sky, or in other words, close to the zenith, or close to being overhead. But if you use a manual telescope like me, especially if your telescope cannot point directly overhead, then try to photograph the planet when it is already very high up into the night sky, but not close to the zenith, like around 50 degrees above the horizon, because sometimes photographing the planets when they are in the zenith can be difficult. So before you start to photograph the planets, another thing you should take into consideration are the seeing conditions, because depending on the seeing conditions when you photograph the planets will also determine as to how good your planetary image will be. The seeing condition is determined as to how much water vapor is in between you and the planet. The more water vapor there is in the atmosphere, the more wobbly your footage of the planet gets, and that can affect the quality of your image. So if you photograph a planet and there's a lot of wobbly motion, then that is a bad seeing condition. But if the planet itself is very stable and doesn't have a lot of wobble to it, then that is a good seeing condition. And your seeing conditions can vary from time to time because it all depends on the weather. And the seeing conditions are also determined as to how hot your area is, as well as how much turbulent airflow there is in the upper atmosphere. Also, by the way, if you're using a telescope that is, say, a Newtonian telescope, try to make sure to reduce as much unstable air currents within the telescope tube as much as possible, because that can also affect your image quality in the end. And in terms of weather forecasting, you can use an app called Windy in order to determine the weather forecast for your location in order for you to determine the seeing conditions in advance. And also, by the way, before I forget, make sure that you collimate your telescope first before you start shooting the planets, especially if you're not using a refractor telescope. Refractor telescopes, on the other hand, don't really need collimation after being created, unless if your refractor telescope has been through horrible damage. And there are already many tutorials out there online that you can use to determine as to how you can collimate your telescope. So when you're done with all of that, you can now bring your telescope out into the field and point your telescope to a planet in the night sky. But before you start capturing the planets, don't take pictures of the planets. Take recordings instead of images. But if you're using a smartphone, you might be better off with images. But using video recordings of the planets will allow you to do lucky imaging on it and get more detail on the planets. So since this involves doing lucky imaging, this will also mean that you need to have a computer with you and the programs PIPP and Autostakkert3 in order to do lucky imaging. However, if you're using an all-manual telescope like me and you're trying to capture the planets, before you start shooting the planets, you'll need to put the planet right at the corner of your field of view so that the planet will fly across your field of view, giving you the maximum amount of time on the planet itself. But if you have a star tracker with you, then there's no need, and you can just center the planet in the frame. So once you've acquired everything that you need, you can now import your video files onto your computer and do lucky imaging from there and edit your final image. Also, by the way, I was gonna show you as to how I edited my latest image of Saturn that I took from my last vlog, but unfortunately though, I already deleted it because I wanted to pay way for more space in my computer long before I had the idea of making this video, so it was a loss. But one thing is for sure though, all that I did there was simply do lucky imaging using PIPP and Autostakkert3 pretty much the same way as to how I edit my moon images, but except this time it's by using a video recording I took of Saturn. And after Autostakkert3 has outputted a stacked image, I then further sharpened Saturn using the wavelets in Registack 6 to bring out more detail. And that is just a short summary of the thing that I did. However, there are already tutorials out there online that show you as to how you can edit your planetary images in order for you to get the most amount of detail from them. And all that I did is simply follow a tutorial that I found online for editing Saturn. So that's it for this video guys, and I hope that you found this video useful and informative so far, and hopefully that you learned something new from this video that can help you improve your planetary astrophotography skills. So if you're planning to enjoy the night sky anytime soon, especially the planets, then I wish you good luck with your planetary astrophotography and stay safe.